All right, howdy everyone. We're going to calculate the limit of a rational function as x is heading off to infinity, and we're going to look at the case where the denominator has the larger degree. So here's our example. You see the denominator has degree 7 and the numerator has degree 5. And we'll do it two ways, but the trick for the first way is to factor out the degree of the numerator, then x to the 5th, from both the top and the bottom. So let's get started. It's the limit as x goes to infinity. We're factoring out x to the 5th, so that leaves a 2 plus 4 over x cubed on the top. And the bottom, we factor out x to the 5th, so that leaves a 3x squared plus a 1 over x to the 4th in the bottom. We, of course, have cancellation here of those x to the 5th. And so that leaves, on the top, 2 plus 4 over x cubed. And down the bottom, 3x squared plus 1 over x to the 4th. All right. Now, since x is going to infinity, 1 over x and 1 over x cubed and 1 over x to the 4th, they're all converging to 0. So this term is heading to 0 and this term is heading to 0. However, this term on the top is just staying, that term is staying at 2, but the x squared is heading off to infinity. And if you add the 0 to it, the whole bottom is heading off to infinity. So it looks like the top is trying to converge to 2, and the bottom is trying to zip off towards infinity. Well, if the bottom is heading towards infinity, 1 over that is getting really, really small. And if you multiply it by 2, it's still getting really, really small. So the answer will just be 0. All right, so that's one way to do the problem. There's another more sort of heuristic way to do it. Let me look at the original problem. 2x to the 5th plus 4x squared. All divided by 3x to the 7 plus x. Now, the way to think about this is as x is getting really, really, really big, x to the 5th gets mind-blowingly large. It's so large that terms like the x squared hardly even matter, and terms like the x hardly even matter. But on the top, the only term that sort of really is dominating and really matters is that x to the 5th. Everything else is just small potatoes, and the bigger x's, the smaller potatoes they are. And on the bottom, the only term that's really mattering is this x to the 7th, and all the other terms matter less and less as x gets bigger. So it's a theorem that this is true, that you can look at just these, what they call leading terms, 2x to the 5th, 3x to the 7th. And when you do that, you see you've got some cancellation going on. You end up with just 2 over x squared. And since the denominator here, x squared, is heading off to infinity, 2 over it is converging to 0. And so that's the answer. All right, that's it. Ciao.